which it's a little bit more developer driven. How many people are actually engineers? 2, 3. Okay. Are you guys marketing managers? What's your kind of all over? So these 3 tools kind of to go for everyone. Even though that you're not an engineer, they're going to help you understand how to communicate with your engineering team. No matter what your team size is, these tools are going to benefit you. Whether you're 100 engineers, a startup, even if you're working on a project on your own, you can still utilize these 3 tools, and they're going to help you make less mistakes during the development process. They help, they really kind of cover your ass when you screw up. These are going to catch it. And the end users aren't going to see these, they're not going to really know you're using these tools. But you're going to release less bugs, you're going to be able to fix bugs quicker, and you're going to be able to develop features quicker and get them out quicker. So the first thing is source control. Source control is probably the most important tool you get out of any of this. If you start falling asleep towards the 2 or 3 slides in, remember source control. Source control, you can't do anything else without having source control in your tool set for your developers. If you're working with developers now, ask them, make sure they're using source control because it's the most important thing out of all this is source control. Continuous integration. Does anyone know where that picture came from? Integrate all things. I've never seen that. I saw that. I Googled and this thing popped up. So I was hoping it wasn't some stupid joke that I missed a long time ago. But continuous integration works in with source control and is really the thing that is going to be the key that ties these other 2 tools together, and it's kind of your central platform. Test automation. You can get by without test automation. It's not recommended, but you can, so it's kind of a less important thing to have. But if you're working on any kind of big project, especially if you have multiple developers, especially if you're outsourcing, you're going to want test automation in place. It's just it's gonna help you sleep at night. It's going to prevent you from pushing a release out and blowing the whole thing up. So the effect of all this, using all these 3 tools, and I'll get more in depth in each one, but the effect of using these was actually best summed up by Kevin Scott, who was hired onto LinkedIn a few years ago. He came from Google. The first thing he did when he went into LinkedIn, this is before they went public, he spent 2 months completely shut down the development process and implemented what he calls continuous development. And you can check out this article and kind of read a little bit more about it. It goes a lot into the source control stuff. But what it doesn't tell you is how he did it. And I'm going to be kind of explaining how he did it. One thing he does mention in this article is something about source control and branching. I'm going to delve into a little bit more of the branching models for source control. In the article, he recommends not to do it, and he says that's what he got LinkedIn away from. But I don't know personally, but I'm pretty sure he backed off the full use of feature branches. And so it's kind of misleading when he says that in the article, or whoever's doing the article about it. But I'll explain that later when we get to it. So let's see. Source control. So source control is your code repository. It's pretty much a server that backs up all your code, stores it. It has version control. When a developer comes onto the project, he syncs the code down, and he can work out of the source control files, and he checks files back into source control. Has anyone seen Silicon Valley, the TV show? Remember the episode where that kid, the Carver, he came on and he mutilated the code, right? That was the episode that said this show is completely false. I'm going to throw everything out now because any startup is probably going to have source control in place. Source control prevents that from happening. If someone comes into your code and mutilates it, does whatever they want to it, checks it in, commits it, it goes up, source control allows you to undo that. Just completely back everything out and start over. There is so many things that source control will save you from. If you don't have it in place, you're bound to get you're bound to have something screw up and you can't revert. It's your ultimate undo button. It's also, if you have more than one developer, you pretty much have to have it because if you have a developer working on the same file, they can't share files. Source control is going to allow you to, both of those developers, check in the same file, merge it back into the main branch without any kind of conflicts. Some of the source control tools, Git, I'm sure most of you have heard of Git, SVN, Subversion, Perforce. Perforce is I think they have a free version, but it's what EA Sports uses. It's a pretty big corporate level source control. I don't recommend that for any of you guys. Git is probably the best version control out there. It's quick and it allows you to do all the branching that I'm going to be talking about in the next slide a lot easier than any of these other ones. Dropbox is not source control. If you're using Dropbox for source control, you're doing it wrong. Dropbox, they have a version history, but you don't have the same kind of history that you have for source control. It's not the same. You can use that to store like art asset files, stuff like that, marketing material. Put that on Dropbox. Don't put that in your source control. You don't need it in source control. Put that stuff on Dropbox. Put your code into source control. So the power of source control comes from, you get a lot of benefits from using a branch type of source control. Git allows you, actually all the source control allows you to do this. Git allows you to do this easier. If you can't quite understand this, feature branches are what your devs are going to be working on. They pull out, they pull it off from the main line. They work on their feature. They can work in an isolated environment. Once they're ready for that feature to go, they push it up to a development branch. The development branch is going to be the all your features coming together. It's going to, there's some different names here. Test, some people call it test. EA uses DLMLRL, which is dev line, main line, and release line. So there's all kinds of different names. If you jump onto a startup team or go into a company, they're probably going to have different names for this. This is Git's way of doing it. SVN uses trunk as their master branch. But once a dev pushes it into the development branch, they can then test it. Once it's ready for staging, here they call it release. They push it up to another branch that is kind of your internal beta branch that you can test everything off of. Once you're happy with that, then you push it to your master. There's different ways of doing that. This is just one way. Whatever what tool you use is kind of going to determine what kind of branching structure you use. The other cool thing about source control is hotfixes. So if you push something out and you don't find the bug until it's in the live environment, you start getting emails from people. And it's been 2 weeks since you pushed that out. Your devs have since then been working on features. Source control is going to let you go back and grab your master branch of where that release happened, pull it down, fix the bug, and push just that back up without pushing all those features that you've been working on for the past 2 weeks. So it's going to save you if you get something in a live server being able to fix it. It's also going to help you always have a working copy of your game. If you have an investor drop in, you want to have a working copy of your app. if your dev's over working on his own source control, he's probably got it broken somewhere. And you're not going to want him to build the app real quick and show it. You can go on and grab another branch, build it, and show your investor the latest working copy. So it's really important to keep these branches separate. Does anyone use agile development? Know what it is? So the thing with this kind of works with that with agile feature branches. So if you have a 2-week sprint, so if you're working on something for 2 weeks, your devs are working on feature branches. At the end of those 2 weeks, you're supposed to have all your features done and ready to publish at that point. That's when you push everything up to the development branch or the staging branch. Whatever branch is stable, so it goes in line with your agile. You should sync it up with your branches. When a feature is ready, push it up at the end of that sprint. One thing you're probably asking yourself is, how do you keep each one of these lines is someone has to go in there and do that, right? Someone has to merge that branch out. EA actually has a dedicated person doing this. He's called a build engineer. He's in there manually pushing these integrations up. And it's confusing as hell when you get in there. You don't want anyone manually going in there to do it, which is where continuous integration comes in. Continuous integration is going to do all of this automatically for you. Continuous integration is merging all your development work into your development branch, publishing it. If your developers are doing that, if you're non-technical, be familiar with the continuous integration environment, the terms that they use. If your developer is out for an entire week, it shouldn't stop you from going in there and being able to integrate, push releases. This stuff is, anyone can do it. It's not, don't think this is your engineering team that has to do this. A lot of times, project managers are the ones pushing out development builds, deployments. They're the ones doing this piece of it. The devs are essentially just checking the code, and they're working on moving the features around. Some of the continuous integration tools. Jenkins is a free one. It used to be called Hudson. If you search for Jenkins, you'll probably find Hudson. Hudson's the older version of Jenkins. Atlassian Bamboo is by far my favorite. It goes with the Atlassian software, which they make Confluence, Stash, Bamboo, and Jira. They have all those tools. So this stuff integrates very nicely with all their tools. Cruise control, I haven't used it personally. Actually don't even know what Continuum is. I just searched for it, and supposedly people use it. So it's another one out there. It's an Apache open license. Let's see. So what the deployment kind of looks like is all your code comes in, releases get packaged up into a version. You have 1.3. This is from Bamboo, which is why the tasks look like Jira tasks. They have task numbers associated with them, so you know every feature or every bug fix that was in that release. Your continuous integration server is going to be responsible for packaging all those up and deploying it to a development environment. And this is a live environment, may or may not be exactly the same as your production environment, but it's an environment that you should be able to test everything on. Again, if you're working with your developers, make sure that they have at least 2, they don't need all 3 of these. Make sure they have a test environment where you can test everything as if it was in production. You don't want to be deploying this thing out to production before you test it in a live environment. And their personal PC is not a test environment. you have to put it on somewhere else for them to test it, because you don't know what kind of settings they have. You want your staging server especially to be exactly like your production server. Your development may or may not be, but your staging is essentially your last chance to see it before it goes live. And it's good to have these in place. The other nice thing about this is if you push development up into production and you get it 1.3 up there, you have these packages to fall back on. So not only do you have source control to be able to revert changes and push another release, you can actually just say, just roll back to 1.2 release. You need that flexibility. You can seriously screw things up. If you don't have the revert button, it's, something's going to happen. So test automation. So let's say you have a developer going in, he's staying up all night, he's working on code, checking in, makes 10 check-ins overnight, wakes up in the morning, makes 10 more. You come on and you check your development environment, which has all these changes in it, and you get a login screen and the app crashes. Now you have 20 check-ins that either that developer has to go back and regress, he's got to go back one by one and see which one actually broke it. Or he's going to go in there and debug the current problem. This happens all the time, mainly because developers are working on a controlled environment. They might not have, they logged in a week ago and now the app has their authentication. They don't go to that login screen, right? So they don't always go through the critical path of your app. So they didn't know that they broke the login screen. So source control is going to help you. One extra tool that you can have to prevent that is test automation. Test automation is something that gets ran after every single check-in. So when they check in, that first check-in of the night that they checked in, it's going to go through a series of tests and verify that what they built succeeds. So in the scenario that they checked in 20 times, they're going to see exactly when their code broke the critical path. And you can get, there's all kinds of different types of automation. Unit testing is your basic. Feature testing is probably where you're going to get the most benefit from. It's a little harder to set up because if you make changes to your app, you're going to have to go back and rewrite the test. So you kind of want to be careful with some of the tests you set up initially if your app's changing a lot. But you always want to require your devs to build some type of test automation in with their features. In some of the places where I've worked, you're not allowed to check in code unless you have tests built for that to test the entire, to test your feature. EA uses manual testing as well, testers. Bugs do not come out of this. This is to verify that the build actually works. Manual testing is separate. It's bugs. Sometimes, especially in games, bugs, there's a gray line between is it a bug, is it not? You get a lot of testers that think they're designers and they go and start saying, well, it should work this way. Well, no, that's not how the actual designer wanted it. That's not test automation. Test automation runs in a controlled environment, builds a code, runs all the tests. It looks something like this. I'm working on a website that's got 250 tests in it. And every time this check-in goes in, it takes 2 hours to run through all the tests. There's no gray line with test automation. Either they're passed or it failed. There's no, well, it passed, but it took too long. Testing is going to test that, especially the critical path, make sure that the critical path goes through before and actually, if you go back here, usually when you build, it runs tests after the build before it builds the release. So if those unit tests or feature tests aren't passing, you're not going to get a version 1.3 put out until you get fixed. So it's part of the process that prevents bugs going through, especially if you have a large code base and you just can't simply test everything every single time. So here's a big picture of kind of how everything ties together. I don't know what this piece, I stole this off. I don't know what this piece is, but you don't really, is anyone associated with live level? Okay, good. So this is an extra piece you probably won't need. So what happens is devs check in the code, GitHub, whatever it is, Bamboo, your continuous integration server, picks it up, it runs all the tests, builds the code. Once all the tests, only when all the tests pass, it builds the artifacts, essentially the package information that you need to deploy. For Android, it's the iPhone app. The Android, it's the app websites. It depends on what you're using, but there's usually a deployment package that gets put out after you build. And then it takes usually a person to, you can deploy this to a development server automatically so that it always builds, tests, when it's good, it pushes out. But it's going to take a person to go in and say, development's good, it's clean, I'm happy with it. You don't want to rely all on your tests. You want to have some manual testing just to go in there and verify and use it just to make sure that it looks fine, because tests, especially in video games, it's impossible to write test automation for some things. So you want to put eyes on it before you move it to a staging and move it to live. But anyone should be able to do that. It's not just engineers that are going to do that. Most likely it's a project manager, someone that verifies the build is okay and clicks a button to say, now push that to the staging, and he'll push it up to the staging environment. Once staging's been tested, then you push it and you release it. So let me just make sure I've got.
Under the user acceptance testing, I see that is selected, right? Your unit test to the right there.
This.
The third one, yeah, the SC check mark.
I actually don't know, honestly. Run user acceptance test. I mean, is that what it is?
I think so.
Okay.
I haven't seen that.
There's a lot of different unit test software. It's largely going to be based on the code base, the tools you're using to build your app. Node.js has its own test environment. jQuery has its own. Everything now has some type of test automation. So easiest way to figure out which tool to use is just Google whatever you're using, test or unit test, and it's going to tell you the tool to use with it. Some have it built in now. I know AngularJS is JavaScript, it's built in now, and then you can get third-party stuff to do it as well. That's pretty much all I got. You guys have, I know I kind of shot through that pretty quick.
So you talked about having a valid test platform to kind of test everything out. So if you're looking at like a mobile device, I mean, iOS is fairly standardized, and there's not that many hardware platforms, kind of less than iOS with regards to Android. Are emulators kind of good enough, or do you really need to keep one of each type of hardware platform to test it?
You want to at least test it on a couple actual physical devices before you send it out. Emulators, they're not the same. I would put that up in the category of that's your dev environment is an emulator. But when you're testing on your staging release before you put it out, you want to get it on a physical device. Again, the general rule is you want to be using what the user's using at the staging portion. If you're at the development portion and you're just testing features, you're a developer, it's okay to use emulators.
Do you do Android development?
I have before. I don't do a lot of it.
So if you were doing it, would you be very specific about the kind of device? Specifically,
yes.
These are the devices it works on, and those are the ones you can.
And I would stay consistent with those two. find 3 or 4 different devices. Put them, keep them at your desk.
Right.
Because you don't want to have people walking around with these devices. You don't want them using it and cluttering it up. Keep them in a controlled environment and push them to those 4 devices. Set down a couple hours and play through each one of those. But don't go overboard. I would say you want your lowest common denominator. You want the lowest Android device that you support. And then you're going to want a few middle of the road, and then you're going to want the top end. You're going to want to get those 2 extremes. You also might want to mix up the SDK that's on, or the operating system to make sure you get kind of exposure. And then you can do those with your kind of middle of the line ones, put different ones. But you're going to get the most information from the bottom of the line to the top of the line. Because a lot of people don't realize you can have bugs from running on a device that's too fast. You always think that you want to go to your lowest common denominator because it's all your bugs. But you get on some of these higher devices, and I don't know Android specifically, all the tech behind it, but if you get on something that has multiple processors, you have different threading models on those devices, you're going to run into different bugs. So you want to test on that high-end device. So, question?
What sort of automated tests do you set up for like a game environment?
Games are hard. It's probably the hardest thing, app to try to test for. EA has gone through that. EA, that's why they have hundreds of testers, because it's really hard to set up automated testing. Your best friend though with games is unit testing. You're not going to be able to test feature stuff as much with games, but a game's set up with a bunch of little pieces, like rendering and physics engine. You're going to want to set up a bunch of unit tests, testing a specific area of the game, a specific area of the code, just to make sure you're getting your input-output correct. And if your code's architected correctly, you should be able to isolate those pieces and essentially just run black box test on it. But you're going to have to get eyes on it. EA is still trying to figure out how to automate testing. It's really not possible. I mean, you need to see the visuals of a game to be able to test it. Because there's all kinds of bugs that just come from it doesn't look right. There's also a lot of gray areas. And if you have testers, they're going to start getting into those gray areas. So you really have to have something in place to kind of set the rules up for them. And if you can't bug design type, you want to say, bug it if it crashes. If it crashes, that's enough. Like set up criteria for them to be able to test it. But the best thing is with games is to get the continuous integration in place where you're pumping out a build every time something gets checked in so that you can actually sit there and play with it. Any other questions? Yeah.
Can you just talk about any of your experiences with a non-technical founder and how do you invite them into any of those processes?
So I'll actually talk about not a non-technical founder, but I work with clients working with startups. I do contract work for them. And we work with clients that are not technical. That's why they're coming to us to build the app. They do not want, they're paying hourly. They don't want to pay for all this. And it takes at least a few weeks of convincing that you need this in place. And it's one of the hardest things. I still work with clients that eventually just say, no, we're not paying for that. We don't want test automation. We don't want continuous deployment. We just want you to give us these features, and that's all we're going to pay for. Once you get this, if you convince them just to get this in place, it's going to take you it's going to take you 3, 4, 5 days. It took LinkedIn 2 months to put this all in place. But they're of course a huge company. You want to get this in place day one, first thing. If you do a discovery session with a client, or if you're doing prototyping, you want to get this in place first. It's going to save you so much time later that it's worth doing it right off the bat. If you can get it in place and just get a 3-day task in there to work on this and get it in place. Once you start working on features, build this into your estimates. Build in that you need to write test automation. It's going to take you several hours. If you're working on features, it's going to take you several hours. Build that into your estimation. Don't say, well, I need to work on this feature. Once I get it done, then I'm going to build all these tests, but I have to update our continuous integration to deploy this differently. Don't present like that. Say that this is what it's going to take to build this feature, and just include it in there, because they're not going to like it when you say, here's a feature, it's all working. Oh, but I have 6 more hours I need to do just to make sure that it's not going to break down the road. And eventually, if you work with them long enough, 6-7 months, this stuff's going to, and they don't have it, this stuff's going to come back and start biting them in the ass, and they're going to say, well, why is there so many bugs? And come back and say, well, we didn't do this. Will you let us go do it now? And then go back and implement. But it just kind of takes, kind of got to get bit first before they realize that they need this. And it will happen. So.
What about, do you have any recommendations for IDEs and how it connects to GitHub and the unit testing?
So I use Visual Studio mainly. I'm not a big Microsoft person. Most IDEs have this stuff built in. Eclipse especially has all kinds of plugins. Visual Studio, Microsoft's kind of getting away from this, but once you go Microsoft, you have to stick Microsoft, and it sucks, but they're trying to get away from it. A lot of IDEs have this stuff built in, have the deployment stuff set up. Microsoft has a source control called Team Foundation. I don't necessarily wouldn't recommend it. My wife works at SunGuard. They use it on their team. And she says it's good. It integrates directly. But there's no need to get it all into the IDE. The one bad thing about that is that when you get the non-technical people, the managers, the producers, they're not going to want to set up a dev environment just to get to this stuff. It's better to set it up into a web interface. Use those tools as a developer, but don't rely on them. Use some type of external tool. Atlassian, Bamboo, all their products, they're all web-based. It's the best way to go just because you don't need all this crazy setup to do it. You can do it from any device. It's just a browser. You go on there and you can deploy all of it. So, Amazon Web Services is starting to build some deployment tools called Elastic Beanstalk. I don't know if anyone's dealt with that. It's starting to overlap some with the development, the deployment, continuous integration piece. You want to try to keep everything central as you can. With Bamboo and Elastic Beanstalk, you can kind of draw the line and merge those together. I personally don't do that. I keep everything in Bamboo until it's ready, and then just push it up into tell exactly what Amazon Web Services what to do instead of using the web services tools to manage deployment. So you want to keep everything in one tool as possible, integrated. It's just gonna help everything work together because this stuff has to work together seamlessly.
Right.
You don't want to be exporting into something else so that another program can import it back in. You want one thing that does it all. And Atlassian, by far, is probably the best product I've seen that does everything together.
So the continuous integration piece, that will automatically upload it, I guess, to your server running?
It can.
It can, okay.
Yep, you can write scripts. Continuous integration is just like cron jobs. They just run. They watch your source control when something is checked in. They run a set of jobs. So you can pretty much do anything you want with that.
Okay.
That's what's going to fire off your unit test and all your testing. and most of the continuous integration tools, Node has a test piece that knows how to read results to be able to. The other big thing to do is set up a notification system. Most of them have it. When someone checks something in and breaks the build, you want to get an email immediately. You want to know who it is. Put the name, you know, at EA, we used to have lights set up that were set up to the computer that as soon as something broke, it turned red and started flashing. You don't want any kind of broken code. You treat that as critical bug fix, immediately go in. So you want to be able to know when that happens. And you don't want to rely on your devs to see it. You want, as a product manager, you want to see that and make sure you come down and say, look, you can't have broken code. It's one of the worst things to try to, once you break it, especially if it's in the main branch, you pretty much take down all your other devs. They can't run something, you break it for them as well. So you pretty much halt production when that happens. So you want a good notification system set up to let you know if something happens.
Thanks.
Anything else?
Cool, man. Well, thank you. So, you can obviously get a hold of Jeremy at, I love that you have workingprogrammer.com, as in, if you were not working.
That's my blog. I have a bunch of articles and stuff up on there, so if you want to find out more. My wife also blogs on that, so a lot of good
Is
stuff.
your wife a programmer?
She's a software engineer at SunGuard, so she has a lot of, she actually
Do you guys
worked
have a
on
red
Madden.
flashing light in your own house that if
No, but I've
the
thought
code
about
gets
it.
broken,
I have thought about it.
gotta fix the code before the end of the night?
Luckily, we don't work on the same project.
They always say don't go to bed with broken code.
That's right.
It's a good one.
So all of that. All right, well, cool. Thank you, this is Jeremy, and take down his information. And then again, Thursday, 12 p.m. Next Monday night, we're also not going to be doing Founders Talk. We're going to be doing our own local thing for just the starters here. So plan on skipping next Monday night, and then look on the meetup.com/starter-studio, and you can find out more information about upcoming events. All right, if you guys could grab a chair on your way out, it'd be helpful.
Thanks, Tom. How you doing?
Good job.